Okay, let's see some examples and talk about assignment number 4, and then we will take a lunch break and we'll come back and we'll do other stuff after that. So what do we have here? I've gone out to the website and I've gone out to the lecture examples directory of down here on the bottom, and I'm showing you that there's about linked list, hash set, hash map. If you click on these examples, some of them, that's the output, sorry, like this one example, some of them bring up the source code. I've selected some that are more interesting to look at, and I'll bring them up and zoom them in inside of Eclipse so we can kind of go through some of these and see. But before I start doing that, I kind of want to show you the example, excuse me, the assignment. This is assignment number 2. So let's take a look at assignment number 3. Thought I had it up. I probably do somewhere back there. Yeah, zoom. Okay, assignment number 3. After you've done your inheritance from assignment number 2. This one? Yeah. The first one was just regular object. It was like hello world. The second one was inheritance. The third one is this one. Extending hash map. All of the files you're going to need are going to be out on the website. I was just there a few minutes ago. They're going to be here. And the assignments that are specifically mentioned in the assignment description are going to be in the assignment section. So here's our hashmap.html, which is going to give you the kind of the current version of what's going on with the hashmap class. You're using something that's built into Java, java.util. You don't have to create this on your own. You're given the multimap.java class here, and you're given the base hashmap multi-hashmap class that extends hashmap, which implements multi-map. So the assignment is threefold. First, it's showing you how to use interfaces. It's actually setting up the interface stuff for you. It uses interface classes, or interfaces, and they're not really called classes. It's using inheritance, interfaces, and it's also using multiple interfaces, but it's also using the collections, java.util collections class as well. So it's really packed, which is the reason why I only have like 4 assignments that you have to do. Each one of them is actually kind of packed with a lot of concepts in it. Here are the other support files, everything that has 3 next to it. And then there's also a how-to video on that as well. Not going to be quite as helpful as number 2. Number 3 is going to be a little bit more difficult for you than assignment number 2. Maybe not so, but let's take a look. So the goal is to extend the Java-defined hashmap class. You're given that class. To add the ability to store multiple objects. So to do this, you'll need to edit multi-hashmap.java, also found at the same location, to both add new methods and override 2 methods of the hashmap class. So you need to implement 4 new methods and see the multi-hashmap.java file. In there, there'll be some comments to tell you where to implement them. The get all, the put all, the contains, and remove. You need to override. So you're going to implement these 4 new methods. You're going to override 2 methods of the hash map. It means the methods of the same signature and the return type. And I mentioned, I think I talked about overloading and overriding already. So when we override, we rewrite essentially the functionality, and the only way to rewrite it is to use the same name with the same signature, which is the list of parameters. So if we create 2 methods with the same name, same parameter list, we're overriding it. Essentially overriding it, if you want to call it that, but overriding is the term they use. And you can read through the rest of the behavior, and here's a sample output here. So basically you're taking this pre-built code for you, and you are, this is the first part of it. There's actually 2. There's exercise 1 and there's exercise 2, which is a sorting, to use an iterator essentially. But in the first part of it, you've got multiple objects that can be organized inside of a single object in terms of this collection framework. It's working with the collection framework. This is the test output that you've got. So you'll have to go out and read the rest of this more thoroughly, and you'll have to go out and look at the examples and put all the pieces together and implement an override. Implement 4 methods, override 2, essentially. So the second part takes and creates, so you're using the class of util collections, and I'm going to show you this up in a few minutes. Do not confuse this with util collection, which provides many useful static methods for collections, list, sets, sort, binary sort, and this is the part I'm going to actually show you. So in this, you're taking collections, plural, not collection. So we're going to implement collections.sort. So we're going to, in this exercise, I'm sorry? Oh, I thought someone said something. We're going to utilize the sort method of the list to the abstract type. Collections are list. Use the comparable for elements in the list to compare one item with another. Is somebody talking? Oh, maybe she. Oh, she was. So I'm sorry. Like I thought I was hearing noises. So no, I'm not hearing anything yet. Somebody was on the phone. All right. Read through the description at your own. We're modifying rat_number.java code, which is in the bhacker directory, along with the other code that we just looked at a few minutes ago. Making some modifications to it to add a comparator, essentially. All right. So there's 2 parts to it. Both parts are, the first part is a little bit more challenging. The second part is actually kind of easy. Then you'll see the rat number, random number, and we'll see all the other supporting code in that directory. And then watch the video, and you'll see a lot more information in terms of the implementation. But let me just go through a couple of examples to give you a feel for how the collections is going to work for us. So here's your basic set, and this is going to hopefully give you kind of like maybe an anxiety check, so you can basically remove any anxiety that might be associated with this assignment. If we import java.util and outsir and main, and this one's called set example. All of these examples come from the bhacker.com website. In here, in the set example, we're creating a set, which is going to be equal to new hash set. And we're going to say set add 1, set add 2, set add 3. We're adding items to the set, and we are just printing stuff out. And you can kind of get a feel from this particular example. Here's all the code, actually, in this entire example. That we just create the set. And we say new hash set, and new hash set is coming from the java.util. So if you go online, take a look at the collections interface and some of those links that I've given you in the assignment description and in the examples directory, you'll see the whole list of items that you can create, objects that you can create. They're automatically built in for you. And if you're a C++ programmer and you've created hash sets and things like that in the past, you'll see this is so much easier. You don't have to create any of these objects, you just create instances of these objects that are already built in for you in the collections class. So here's a hash set. And this is how easy it is to add items to the hash set. We could actually go through and sort it. We can go through and run all the other methods, but a lot less work than you'd expect. So here's another list example. That was a set. Yes? Mm-hmm. Actually, believe it or not, this one you can. Here I'm using raw types. This is actually an interesting question. You mean like this? Where I've mixed and matched. I believe this is going to work just fine because I haven't set the type of the object. Here it is. Yeah, it's going to work just fine. I've mixed and matched because I'm treating them as objects and I'm not trying to run any of the iterators. I'm not trying to run any of the specialized methods on it. Technically, you can sort of break the rules and create a hash set that's got different object types in there. If I were to take this warning out, this warning says checked. This warning is just an Eclipse message actually because I haven't set the type. If I set the type to add the type, I'm going to add a generic type because I'm using generic objects. If I do that, let me just show you what happens when I do that. I get comparable, which are just, it's a generic comparable type. If I said these were strings, where this is what's really referred to as typecasting in Java, which, and you know, if you compare it with C++, well, you know, string. How about string? Hello. I put actually the word string in there, and then here I have to change this to 3. This would be definitely be more standard in terms of what you're supposed to do, but you can break the rules. And but if you're going to use a generic object, use comparable as the type, which means we're just going to be able to compare. We're not going to do any of the specialized functions on them versus just adding and removing from a list and just keeping the list. We can actually mix and match the types. There's nothing wrong with that. And we're just using raw type object, because if you think about it, everything in Java is an object, and the comparable is basically saying, or actually I could put the word object up here actually as well, and mix and match different object types. They're all of objects because they're all inherited from object, which makes it violates the C++ kind of thinking about, you know, keeping, you know, liked types. So we don't have to worry about that actually, because everything resolves down to object, which we don't get in C++. But good point. I didn't actually give this a data type, and this is a way to cast the type to string, integer, float, comparable, anything I wanted to do object. I believe the word object should work in here just fine, as long as I go here. Yep, and it's going to give us, well, I've got comparable down here. Let's just do object. Comparable would give us comparable as the object type, which would actually give us the ability to sort it, to do one before the other. But this should run as well. Yeah? Yeah. Target variable? As long as it's of the same type. If I said object obj1 is equal to anything, I could assign it any type actually, as long as it resolved down to object. Normally I would deal with particular, this is a very strongly typed language, believe it or not, even though you can violate it completely like you just seen a few minutes ago. You would have to, by following the rules, the compiler is going to give you an error if you mismatch the types. So if you create a reference to an object of a particular type, the object that you assign to it needs to be of that type. And normally you would use the specified object type. So if it was a string, it was a string. It was an integer, it should be an integer, float. In normal, everyday practice. This is flexible. Normally you'd want to put string, integer, float, double, whatever it happens to be, because if we start using some of the other methods, we want to be able to treat it like a string. A string is an object. If we go more specialized, then we can go further down the hierarchy in terms of the specialization and use the features of this as a string and not just as a generic object. But I don't know if I answered your question. Yep. Normally you see this as a string, and then we can pass this string as an object to a method call if we wanted to take generic objects. Let's say C in and C out takes objects, actually, because we can C in a float, a double, a string, and whatever. We could C out a float, a double. It's polymorphic that way. But they're all objects, so it allows us to make all of the objects compatible in terms of the method call to print everything to the screen. So otherwise we would have a C in float, C in double, C in string. If we just say C in object, then whatever we give it, and then that can be converted to whatever it needs to be. If it's a string, it can be treated like a string, a float. By doing a reference, actually. We could take the string, assign it to a reference string variable that references a string, and then voila, we turned it into a string object. So it does dynamic type conversion with that reference. So going back to that other thing I said before about that person that was an abstract class, we created a reference object, a reference to be used with an object. When we create the object and we assign it to initialize it to the reference, it gets dynamically typed for us. So that object turns into a person when we assign it to a reference to a person. Because it's kind of weird how that automatically happens. And it's kind of different than C++. C++ we have to typecast it. We would have to say string to the string, float to the float. Float f is equal to 1.02f. And you say type. That's a typecasting saying treat that number like a float and assign it to. In Java, we don't have to. We could leave off the f. We could just say it equals to 1.029, and that 1.029 would be converted to a float value when it was assigned to that variable. In Java, which brings up another interesting point, we have variables and reference variable. They're really variables, but the references. Everything in Java is dynamically allocated, and it's all passed by reference, and it's all reference, which is weird because it's the opposite of the default behavior in a C++ environment, which is all passed by value and value-oriented. But everything is dynamic. In Java, it's static by default in C++. So it's kind of it's interesting to see the differences between the two languages that are both doing the same thing, but they're implemented so differently. So. All right, what else do we have here? For everybody who hated C++ linked list, here we go. Don't know, have you guys ever created linked lists in C++? If you have, you're going to hate C++ now. Because now we have java.util collections. Okay. Public class, and remember there's collection and collections. There's two different packages there. So these are all coming out of collections. And if you read that assignment, you'll kind of see the differences of part 2. Public static, void main, linked list. And now you can see I've actually properly set it to be an integer. So I've assigned the type integer to this linked list LL, and I'm going LL add -8, 20, -28, and I'm just creating some stuff. And then I created a comparator. That allows me to take the collection, treat it like a collection, and compare one item in the collection to another. Comparator is going to be R collections.sort the linked list using the comparator. Just essentially feel that, imagine that all of the pieces of the structure are broken out into separate objects. The iterator is a separate object, the comparator is a separate object, the linked list is a separate object. We have multiple objects running inside with each other, working with each other to accomplish these goals. I think that aircon got to my nose. Comparator, integer, which is it's going to hold an integer, so we have to reverse order on the collection. So we're going to reverse the order of the linked list. So we have the list sorted in reverse that we're going to print out. So for I, this is kind of non-standard Java kind of syntax, but don't worry about what we're doing. We're basically going through for I to the end of the linked list, which is the syntax you're going to be able to use here. And what you want to do is just take the examples and study how they're being used, and all the method calls that are being. Here we have a shuffle of collections to shuffle the linked list. Move it all up the list. We're going to shuffle the list, and we're going to print it out. And we're going to also print out the minimum and the maximum value by running a method call on the collection for minimum and maximum. And you're not going to know what any of these methods are until you look this stuff up. Or look at the examples and kind of see, oh, I remember there's a minimum. I remember there's a maximum on this collection, this linked list. And here's the results we get. We get the list sorted in reverse order. We get the list shuffled. We get the minimum value. We get the maximum value that come out of the list. So it basically takes, and I don't know how many lines this is. It's not that many lines of code. If it were a C++ program that did all this functionality, we're looking at about, I don't know, half a dozen. A lot more work, I should say. So you might say that Java is an improvement upon C++ in terms of the collections, the ability to actually work with this stuff. And this is not the only thing. If you consider the thread libraries, if you consider the I/O libraries for file I/O, database working with JDBC and stuff, the Java packages that work with this. Just like this, a lot less work than in C++, which is like a lot of people like Java versus C++ because there's a lot of it's implemented in the language. Here's a list iterator example, unless anyone had questions on that last one, the linked list. And I'm going through these kind of on the fast side just to kind of show you what they are. I don't expect you to learn everything about the example. It's kind of, you can download them from the website, look at them yourself. I'm being lazy with this one. This one is going to create an array list, which I've actually seen so far in another example. I didn't put a data type on here, which is why we're getting this suppressed error message. This is only an Eclipse warning. If we were doing this with Notepad, we wouldn't have to do this. A Java interpreter is not going to complain about there not being any about using raw data types. And when we use raw types that are unchecked, it says basically, I'm not going to assign this array list AL. I'm not going to say it's a string, a double, a float. Instead, I'm just going to put characters in here. Actually, these are strings. So I said array list, called it AL, and I'm going to add some stuff to it. Now, just like the comparator on the collection of this set, on this is a list, so I'm going to use an iterator. Use the iterator to display contents, and here I have iterator ITR, an AL iterator, run this method. Does it have a next object element? And here I'm using it as an object. Element is going to be equal to the next one. If let's say I typed and I actually put string in here, which I can do, I can still use object because every string is an object. So for every object element, for every element that is of object type, essentially. So I'm treating them like objects, and I'm going through the next, and I'm printing out the element. Just simply printing out the object. Object's holding a string, so it's going to print out correctly. It doesn't actually matter. This one here, I can actually go in here and say string. I'm going to still get the. I'm still going to get the same results, actually. Mm-hmm.
And when I get to array list type over here, so when you print it out, the values of the array list, so does it consider the values as string, or do you consider that?
No, not by default. They happen to be strings, which is why this works. It would actually print it out just fine if it were a float or double, an integer. If it were an object that didn't actually have like a value of that, the element wasn't a value that was printable, it would print out garbage or object reference code that would give you usually an @ symbol and some other information associated with the object itself. It only works in this particular case because the element is the next. The next is bringing back the raw form of the element, of the object. And the next is the item that's being stored in the add. This next method is returning the string, the number, the integer. This would work here if I change these up here to numbers.
So my question is, if we instead of putting string from here,
Mm-hmm.
if we add an object to a class to create, right?
Mm-hmm.
Let's suppose we have a class and we have variables and functions over there, and then we add objects to those classes over here. Then how are we going to get free from
It's the functionality, the trick's right here in the next. The next is bringing the element value. And it's going to bring it back in its raw form because I didn't specify it. If I specify, it's still going to bring it back in its raw form. It happens to be a string. This method call here is going to print out whatever I put in here. So this method is going to actually do the conversion to a string for me. On element, an element is an object that is equal to the next value that next is pulling out of here, which is why it works. It's kind of like the CNC out if you think about it, but system out converts everything to a string for us. It's already a string. But let's say, for example, I said, integer. Let's just leave it out, actually. I'll just make these integers. It's still going to work. It's still going to work. Because when I say this is going to resolve down to 1, and that's going to be 2, And when it gets put into here, added to the string, it's going to convert it to a string for me. So it's going to be a string. It's we're not really relying upon the format that's in here, more along the format of the system out and along in the next functionality. And next is returning the raw value. And the raw value can be of any data type. Because then this would not be very useful if it would only work with strings or only worked with doubles or something. If that makes any sense. It's really this that's doing it at this level, and this that's doing it at this level. And whatever data type here that's doing it at this level. It's not as strongly typed as you'd think. Bottom line. It's actually, let's just see. I just want to see something real quick here. Yeah, it's going to print it out. It's going to mess up the order though, because I have 1, 2 modified elements. Oh, this is adding a plus to each one of the elements, and it's reversing the order. So it kept it as 1, 2 instead of A, B, or whatever it was before. It treated it as objects. Essentially, I never put a type up here. If I did specify a type, if I go like this and go string, I'm going to get the same problem I had before. I have to convert this to a string. If I specify the type and don't treat it like a generic object, then I have to specify the type when I assign it, which is strongly typed. But even though it's strongly typed, you can break the type by treating everything as an object, which is not what I would call a safe thing to do. It's avoiding type. You're using raw types instead of types, and the raw type that you're using is an object. You can also substitute the word comparable, I think, as we've seen in the other example. This, though, however, this array type is generic. It can take any type. It can hold any type of anything in the array values. So, more standard to see a type specified, you're right. What do we have? I think I've exhausted all the examples actually for this one. FYI, I'm also teaching a data structures course, and the data structures course has examples in Java this term actually. I don't know, some people are actually taking that class as well. If you download from the data structures methods, in the behacker.com website in the examples column for the data structures class, you'll see these where you're going to get the array list, kind of similar. The linked list, the queues, the stacks, all sorts of different structures. In fact, my stack, which is just a stack, not using anything, and then a stack example here using Java stack, which is interesting. We have queues and stacks, as well as that are actually they're part of the collections concept. So they're implementations of array lists, implementations of linked lists that are actually in a stack. So we can make instances of objects of stacks in this case, and we can use the push and the pop, and it's all of the standard data structures that you'd normally be exposed to in terms of the method calls. So a queue does an enqueue and a dequeue. The stack does the pop and the push, and then all of them have items to sort and to check, is it empty, and what is the next item. Next, to kind of go through the stack to iterate through it. String reverse, I think this one's actually using, this is IO exception. String reverse through stack. Taking a stack of a string and reversing it. That's using a stack, built-in stack. So, the queue is essentially a linked list queue. So it's taking a linked list from linked list, which is, kind of similar to, instead of an array list, this is a linked list. So it's kind of interesting to see all the different varieties that you have, and don't make your own. Use what's built in. Is the general rule. Questions about the examples? Where to get them? Oh, yes? Let's see. They should be in the, oops, I have to make this smaller. They're going to be in the data structures course. So if you go out here and go into data structures, And source code examples right here. Stacks, queues, lists, and links list. This should be a zip file. Yep, it is. It's the only one out there right now. That's the file that is going to have all that stuff I just showed you a few minutes ago. Create a generic project in Eclipse and add it in. I didn't include any of the project code. Or if you're not using Eclipse, you can just manually compile and run them. They should all work just fine. Any other questions? Alright, so we got options. We can break now, or we can start in with IO exception and then break after IO exception. Eventually we're going to have a lunch break. It is about 12:20. I'll leave it in your hands. Yeah, we probably should break. Do we want an hour? Come back at, or 45 minutes as suggested? So if it's 12:20, you tell me. 1 o'clock, 1:15? 1:15? That works? Okay, check out the ITU cafeteria. It's open today. See you at 1:15.